Section 8.2, proving triangles similar by angle. Our essential question: what can you conclude about two triangles when you know that two pairs of corresponding angles are congruent? Our theorem, the angle-angle similarity theorem: if two angles of one triangle are congruent to two angles of another triangle, then the two triangles are similar. So here we have triangle JKL, similar triangle XYZ, and I know that because the angle at K and Y match, the angle at J and X match. All right. We don't need the third angle because we had earlier in the year third angles theorem, so L and Z have to be the same. So all we have to do is show that two angles are the same, and we can show that the triangles are similar by angle-angle. So a lot of these problems we'll be seeing if our angles match up. So in example 1, determine whether the triangles are similar. If they are, write a similarity statement. So we have 90. So we have that angle B and E are congruent. And then I need one other pair of angles. So you can sort of make your decision which one you want to do. We have the 68 and the 22. So either I'm solving to see if A is 22 or I'm solving to see if F is 68. Easiest way to do that, my triangle adds up to 180. I have 90, so the other two have to add up to 90. So if I do 90 minus 68, I get 22 degrees. So angle A has to be 22. So angle A is congruent to angle D. So then our triangles, so they're similar by angle-angle. And it asks me to write a similarity statement. So that would be something like triangle ABC is similar to triangle DEF. And that is my similarity statement. A and B, we're doing the same thing. We're seeing if they work. So in A, we have the 78s that match. So we need to figure out if our others match. So we want to use that our triangles add up to 180. So we'll use this triangle here. 78 plus 31 gives me 104, or gives me 109. Helps if you can add. 180 minus 109 gives me 71. So those match. So they are similar. And my similarity statement would be triangle QRP is similar to triangle GFH. And again, what matters there is how the letters match up. So if you had that in a different order where the same letters match, you would be fine. In B, we have 110, 27, and 53. The 27s match. So if we do 110 plus 27, we get 137. It has to add up to 180. So those two are going to add up to be more than 180. So this is not going to work, and this is going to be no. You don't see that. We could just do 180 minus 137. I would get 43, not 53. So that does not work. Example 2 is asking us to show that the triangles are similar. Okay, so we're looking for a way to show that two angles match. So on example A, we have angle RTV congruent to angle Q. and I need to name this one with 3 letters because there's more than one angle at T. I know that because they're the same. They're both 49. And angle R is congruent to angle R. That's in both this triangle and the larger triangle. That's our reflexive property. So then that shows that that works. In example B, we have the angles that are marked congruent. So angle L is congruent to the angle at N, which again I need to name with 3 letters, which would be ONP, because they're marked. And then I have the parallel lines. So the angle at P here and the angle at N over here, that's angle MNL, they're going to be congruent by corresponding angles. Okay, so this is going back to some of the stuff you can't really see there. We'll move that over a little bit. So this is going back to some of the stuff we did parallel lines, where we have corresponding angles. I could use alternate interior angles depending on what the picture gives me. So then flipping the page over, the next one we're doing the same instructions. We're showing that that is similar. So I have angle C congruent to angle F. And I'm going to write this one out as more like proof, like just to show you how we're showing that, but we're not actually doing them as proofs. Then I have the angles at D that are vertical. Angle CDB is congruent to angle FDE. That's vertical angles. So then our triangles BCD is similar to triangle EFD by angle. And then we're cutting off the page there. Example 3 is asking us to complete the statement. So first it's asking triangle ABC is similar to. So first thing I want to look at is how my angles match up. So I have these angles that match and these angles that match, so I'm good as far as my proving similarity. And then I want to use that. A matches with F. So that is my first one. B matches with E. And then C matches with D. So those two triangles are similar. The part B, it's asking me to plug in for those. So 25 matches with the same as AC. That would match with FD. So 25 over 15. The 12 then matches with the Y. So I would have Y there. If I wanted to solve for X, I would have X over this, which is 18. And I could use that. Here they just want me solving for Y. So we're going to cross multiply. We have 15Y equals 300. So Y is 20. I'm just solving that for Y. If you wanted to, you could reduce the fraction up here first. So 25 over 15 would reduce to 5 over 3. That makes your math a little bit easier when you cross multiply. You'd have 3y and 60, which will still get you 20. But if you're using a calculator, that shouldn't matter. And then example 3, our final example for this, we have a lifeguard standing beside the lifeguard chair on a beach. The lifeguard is 6'4" and casts a shadow 48 inches long. The chair casts a shadow that is 6 feet long. How tall is the chair? So first, I want to draw out what you're looking at here. All right, you have a large triangle. All right, we want to know how tall the chair is. So that is this part. The shadow, realize if you're casting a shadow, that is on the ground. So the 6 foot shadow is here. Then we have the lifeguard. standing here. He is 6'4", and his shadow is 48 inches. One thing to realize in doing a problem like this, you don't want to deal with feet and inches. So when you're seeing something like that, you pretty much always, there's some exceptions, but pretty much always you want to convert to the smaller unit. Because 6'4" doesn't work well as feet. It works great as inches though. So there's 12 inches in a foot. So the 6 foot 4 inch lifeguard is 76 inches tall. And the 6 foot shadow is 72 inches. So we'll use those when we're setting up our problem instead. So we set up a proportion. So the lifeguard and the chair are both heights. So I do 76 over X. And then the 48 and the 72 are both lengths. The 48 went with the lifeguard, so that goes on top. And the 72 goes on the bottom. The key thing here is that you're cross multiplying the same thing. So if there are multiple ways you could set this up. As long as you're cross multiplying the same thing, your setup works. So I cross multiply, I get 48x equals 54 or 5,472. So x is 114 inches. Okay. And here it asks how tall is the chair. So I would accept 114 inches as a height, but most of us aren't really sure what that is. So it's probably a good idea to convert it if you know how. Divide that by 12. I get 9. So I have 9 feet. I have a remainder of 6. So the lifeguard stand is 9 feet 6 inches. And that is our angle similarity.